Hey! Oh, I'm sorry. Sometimes I just do that. Okay, this video is a bunch of practice on all those transformations. And I'm not going to write a bunch on there, but the answers are going to be on there. So what I suggest you do, write the equation down, take a piece of graph paper, put down what you think it is, and then move on. So have the graph paper at the ready. All right, so first one, -2, absolute value of x plus 1. And your time is up. This is what it looks like. No, I'm just kidding. Pause the video and make the graph. All right, so here's what we know. The -2 tells us two things. First, instead of being a v that goes up, it's going to be a v that goes down. That's what the negative tells us. Second of all, instead of being oh, this is going to be tough. Instead of being a v that looks like this, it's going to be a steeper v, a skinnier one that looks like that. The one tells us it moves left one spot. So your graph is going to look like this. Okay, next one. Pause the video. Okay. Okay, so on this one, first of all, the parent function is a square root. You know a square root looks like that, half a parabola on its side. 1/2 tells us that it's going to be fat, meaning that instead of going up sharply, it's going to be really, really flat. And when we rearrange the inside here, and you should remember to do that, we have a negative x minus 4. Okay, the -4 tells us it's going to move right 4 spots. The negative in front of the x tells us that it's going to be reflected across the y-axis. And the -2 tells us it's going to be down 2. So that is our graph. Okay, right 4, down 2, flipped across the y, and way flatter. Anyways, next graph. Go ahead, pause it, make it. All right, parent function is a square. The negative tells us that it's going to be flipped down. The 3 tells us that it's going to be stretched, so it's going to be skinny. We have a negative on the inside of the parentheses, so we should rearrange this to be negative x minus 1. Okay, so we know it's moving right 1. The negative on that x doesn't do anything for us because all it does is take a parabola that looks like this and makes it look like that. So there's no difference. It's the benefit of an even function. And it's going to be up 2. All right, so like I said, right 1, up 2, flipped upside down, and skinny. Okay, so now you have a few of the regular ones. How about some weird looking thing like this? Okay, this is a function. We don't know what it's of. It's bizarre looking, but we're being told it happens to be a function. So now we're really going to put it to test. Do you really know what these transformations mean? Okay, so we're going to deal with these one at a time, starting with f of x plus 2. And again, you should practice this. I think the best thing to do on arbitrary graphs like this, ones that aren't part of our parent set, is put endpoints on each of the segments. All right, and then make your move on each of those endpoints. Okay, in this case, f of x plus 2 tells us it should move left 2 spots. So I'm going to take every one of those endpoints and move it left 2 spots. And here we go. Right like that. Then connect them. That is the transformation of f of x. All right, let's try another one. All right, for this particular one, I'm not going to put the points in there. You know how to handle that now. This is f of x minus 3, so it goes down 3. And so it's just going to look like the same thing, just down 3 spots. Okay, 2 times f of x. This one, a little bit trickier. 2 usually means that the graph is skinnier. So how's that going to manifest itself on this one? It's not going to take the thing and shrink it in like this. Basically, you need to think of this as being twice the original y value. All right, because f of x represents y, twice the y value. So think of the y values at each of these coordinates and double it. All right, so there are the endpoints. This one is at 3. Now it's going to go to 6. This one goes to 6. This one goes from 5 to 10. This one goes from -2 to -4. This one goes from -4 to -8. And there is the graph. And if you think about the way I usually explain things with a skinny, that graph does look like it's been stretched vertically. It does look skinnier. Okay, the next one. The last one, I believe. Yep, the last one. F of -x. All right, that means it's a reflection across the y-axis. So all of those little endpoints you're going to take and you're just going to shovel them over to the other side of the y-axis. There they are, and there they go. And there it is. A perfect mirror image of the original. All right, that's it for this practice. I hope this gets you guys all flawless executors of graphing transformations.